can start now. So a little bit revision, I think. Pavan has not joined the last class. Did you get a time to see the last lecture, Pavan?
No, Dinesh.
Okay, so we started with the linked lists. Did you have? I think you might have a little experience on linked list, but I don't know. You have used it in professional because mostly in embedded system we don't use that much a linked list, but we have STL containers for that. But for starting the STL containers, I am giving a little overview of every container. For example, as you know, there are two types of containers we have: serial containers and the group containers, which are in order, which are in on order. For example, link list, list, vector. Okay, these comes in the linear data structures. So it is like a line or circular line or a doubly linked list we have. Okay, these all come in the linear data structure where the data flows from one point and it is going into a straight line. Then we have non-linear data structure, which is like trees. Okay, as we come in the C, we have trees. Okay, binary trees. uh, and when we come to mapping of it in the C++, we have this STL container called map. So I am giving one background for background understanding. So how these STLs are as containers are working, I am making a giving an introduction to one set of data structure. For example, linked list I am giving simply to understand the list and the vector, because the on the basis of this linked list, the vectors and the list is created in the STL. So that is our first target. After once we complete that, we'll go to the trees. Basically we'll doing the binary trees. Then we will go to the STL containers that contain non-linear data structure. Is that clear? Any doubt over it? Okay.
No.
So I will show you the last program which I have written. So we have started with the linked list. So this is the quick recap for you. So how the each function is working. Then we will be having this delete also. So I will be giving the delete function as well. Last time I didn't got the time to give the delete. Once we have done that, we will see that how we can create a stack. So they are like we have stacks and queues in our functionality. Okay, so how we are going to create a simple stack using a array, and then we will see how to we are going to create a stack using a linked list. So today objective of the this one is the complete understanding of linked list and providing a delete function into the linked list, transmitting this simply linked list program into C++ based linked list. Okay, so that we are going to do. So I have just what I have created is I have created a structure, then I have created different functions. Now we need to create a class that contain all the functions inside the class. 1 second. I've got a call. Just 1 second. Huh?
Yeah, no problem.
Okay, so let me give you this little understanding what we have, a quick recap you can say. Okay, what we have done lastly. So I will just okay. So we have created a node structure which contain data as well as a self pointing pointer. Okay, self-reflecting structure we call it, and we have an head. So first we create head as a null. Then we have created some functions. For example, creating a new node. As we are giving it dynamically allotted memory, as you know, when we do with the DSA concept, we mostly give the memory into the heap section. So as you know, this is a new operator which gives us the memory. Okay, so this is the way to create a new node and enter the data into new node. For example, you have a linked list and you want to add one more data into it. So what you will do, you will call this function and you will put the data whatever you want. This will create a new memory into the heap section and returns a pointer. Okay, this function is clear.
Yes.
Okay, then we have this something called as insert in front. Okay, so what is insert in front is like you have a linked list. Okay, if I go to paint or Excel is good. Okay, suppose you have I will create a new sheet. Okay, suppose you have a linked list. What linked list contain is linked list contain a pointer, self-reflection pointer, and it contain a data. Okay, and linked list had something called as head. Okay, so suppose I have a linked list. Suppose we start from 10. Okay, it has a pointer called next. Okay, this pointer uh, okay, I will give the name over here. Okay, so pointer name will be next. Okay, so this is our linked list. Okay, so this is the linked list and it is the header. This is the next pointer detail. So suppose this is our linked list. These are the addresses. I will start it from 2000. Okay, this is 2000. This is next data will be 20. It will be holding the next node address, which is 3000. Okay, so in this way they are linking, and head will be having the, suppose this person, this is, we can say like this is its own address 1000. Okay, this is the address of next node. Okay, this is the address of, for the sake of simplicity, I have created a 4000. Okay, 5000. Okay, suppose this is our link list. This is 30. This is, sorry, my screen is visible, right?
Yes, Devansh.
Okay, this is 30, this is 40, and this is 50. Okay, and last is null. Okay, now there will be head. Head is pointing to 1000. Okay, so I will remove from this point. Here I will put 1000. Head is storing 1000. I will remove this one. And this next is also will be present over here, and ext. Okay, from this representation you understand that okay, this is our one pointer and this is whole called node, this whole structure called node. Okay, this next pointer is also node type. Okay, and head is also node type. Okay, correct. So what our head is holding is 1000, so it means it is pointing to this point. Here it is pointing to this one. If I have this one, here I will put green mark. Sorry. Okay, so our head is pointing to 1000. Okay, so from the pointer we have this location at 1000 address, we can have 10. From here we can go to the next address, which is 2000. So head can go into this one, head next can go into this one, then head next can goes into this one. So this we can transfer, means we can go from one point to another and we can move till here. till 50 because we don't have the next address. It's clear? Hello?
Yes. Yes.
Okay. Okay. Now we want to add in the front. Suppose we want to add here like 1. Okay. And its address something like 500 something. Okay. So we want to do that. And here it will take 1000 because we need to connect it, correct? And here
Yes.
we need to give
500.
500. So how we do that in a program? Can you try once? How you can do the same thing in program? First thing is you need to create this. I will write the point. First thing is we need to write. First is we need to
create node.
We need to create node. Okay, node will be created from our function. What is the name of function? Create node. Okay. That function will return us what? A pointer address. Correct? What is the pointer address? This 500. Correct? This pointer address head will be having this pointer address, which is nothing but 500. Okay, so head will have a new value which is 500. Okay, now this pointer address, for example 500 is there. Now this pointer address, let's take this pointer address as a temporary or something. Okay, so we have this temporary address. So this temporary address we first equate to head. So we have head and we say head equals to whatever the temp have. Okay, once we have that, now temp will have this next pointer as well, correct? Right? So head next should be equate to what? 2000. Okay, so we'll take a temporary variable and we replace that. So whatever new thing should be, head should be pointing to the temporary address which is 500, and this temporary next which is 1000, this point which is written null should be having 1000. Means head should have now after the operations, head should have 500 and temp next should have 1000. So this is a representation. Okay, let's see it into the code. So insert it. Hello?
Actually, it is modified with temp, right?
Sorry? You're saying something, Pawan?
Yeah, it is modified to temp. After that, how we are able to change from?
No, just for the representation, the operation. I mean, first you need to set the temp next to this 1000. Then you can change the head. That is okay. But I'm just for the sake of simplicity, I'm explaining in that way. That the address should be like this. The process is not like this. That first we need to do that. The steps I'm telling. I'm explaining in the program actually. Okay, so we are in front, we are inserting in the front. So what we will need to do, first we need to create a node. Okay, so first we have created the node. Now what happened is we need this 1000. We need this 1000. Where this 1000 is stored?
Head.
No, sorry. We need this 2000, not 1000. We need this 2000 to be stored. Where it is gone? 1 second. I have something happen in. So new node next will be head. That is store this one. Sorry. I'm really sorry about. Sorry. We need this 1000 first. So this 1000 will be heading in the this one head.
Yes.
Sorry, I'm just. Okay, so head will contain 1000. I was taking the head next actually. So head before, if we go back, so it was having this 1000 because I've changed the name now. Sorry, I have filled the data. That's why it's confusing. Okay, so I have this head which has the 1000 previously. So whatever the new is coming, that needs to hold this 1000. So what we will do is, whatever the new node has created, that will hold this 1000. So that is happening in this program. So we are holding the 1000 which is present in the new node. So now the new node text will have the 1000. Now head will be having new node. So as we have represented, now this will have 1000, and head will be pointing to this 500. So in this way we are inserting in the front. Clear?
Yes, yes. Node of next will be 8, then 8 will be modified.
Yes. Okay. For insertion, we had a at end. If we insert at the end, there is we need to travel. We need to travel from the list. Suppose I want to add over here. So suppose I got a new address as 7000 or 73590 something. I got an address. Okay. Here I need to put the data 60. Okay, and I need to connect this one. It's simple only. First we need to transmit from here to here. So how we are going to do this? We'll make another transmit temporary variable. We point it to the head. Okay, it is pointing to the head. We will travel till we find this null. Okay, so we'll travel till we find this null. So where we will find this null? When temp next,
Yes.
when temp next equals to null. If we
No.
find this place, we find this value, then we can place whatever the new node we have created, that value into it. So we'll fill like 7390, and we are good with it. So this can be connected, and here we will put null. Let's see it's working in the program. Okay, so first we will see, we'll create a node. Okay, first we will see if we had a head or not. Suppose we don't have anything. Okay, and we are creating a new entirely new linked list. So we cannot add it into the end because there is no new linked list. So we need to check if it is null, then the head is directly connected to new node. Point to be noted over here is, as you see, head is a global variable. Okay, that needs to be taken care. Other than this, are local variable only. This new node, this is coming. Head is the point of starting for us. So head is very important. When we are doing operation, head needs to be verified. So from the head we will get all the keys. So now we'll check if head is null. It say, oh yeah, it is null. Then we will create new node is directly equals to head, and we will return the function. Okay, if head is not null, then we'll have a temporary variable from where we'll start transferring. So what will be temp will find the next. If it is not equals to null, we will go inside this while loop. It is still here only. Okay, so no. This is I have done because there is a mistake in the previous code. So it will start traveling from point to point. So again, this will be, it is like temp will having the next value. It will have this. For example, if you transmit from here, suppose this is temp. We have this value called temp. Okay, so temp is equals to 500. Now next value of temp will be temp next. So temp next, we will put this value over here, and we will transmit from here to there. Temp is good. Next we have, okay, so first temp value will be 500. Temp next value will be 1000. Okay, now what happened? Now temp becomes temp next. So here if I copy temp here, temp becomes 1000. Temp next will become 2000. Okay, it will travel till here. Where temp, because temp has reached to this, sorry, here it is. Okay, temp equals to 4000. Temp value will be temp is 1000 over 1000. temp here will be temp value 500. Temp next is 1 second. I need to insert a table. One more. Okay, we'll have this. Delete this one. Okay, from where here we can start. Okay, temp value equals to head. Okay, when temp value is head, temp equals to 500. Okay, here we'll write temp next will be 1000. I will increase the size. I will copy these control C, control V. We need this last one. Okay, here the temp value will be 5000. Okay, forget till here we have connected the node. Not till now we have not connected the node. Okay, so temp value will be here. Temp equals to sorry, here we are. So temp value equals to 5000. Okay, now temp next is null. So we have reached the position where temp equals to null. Okay, so this will break. Okay, this will break. When this function will break, we will have this new node address. What is new node address? What is new node is 709, 7309. So
Yes.
temp next next value equals to 7390. So we have connected this. So this is our main process. This is the way we are connecting it. So what is inserting in the front or in the back is in inserting in the front is we need to it's like swapping of the variable. We have a new thing, we insert it in between and we swap. And what happened in the end, we travel from the head to the point where we find the null. Where we find the null, we change the null to the next pointer where it is pointing, or the next node where it is pointing. Okay, so this is the second this one function. Okay, so and we have, and for the print list it is simple. We will start from 0 and we'll print till we find the null again. Okay, so here it will travel from 5000 to the 7099 until it become null. So we'll print that. Any problem till now?
No.
Okay, now let's see the deletion. Okay, so can you tell me, Pavan, if there is, for example, this is my I will delete all of these. Delete. I think this. Delete. Okay, suppose I need to delete this 4000. How I can do this? This node I need to delete. This H node I need to delete. What can be the procedure?
Yeah, when if you are traveling by element to reach till 40, then after reaching 40, then you can do like temp you are taking. Temp is updated with head. So yeah, So with
Okay,
that,
so
we will travel till 40. After reaching
okay.
40,
Wait. We'll do one by one, huh? That's only theory part. We'll see the program later. Okay. So I have a temp variable. Okay. And I need to delete as an index 1, 0, 1, 2, 3, 4. Suppose I need to delete this 4. So I will take a function called delete at index. I have not created it yet. Okay. So I have given it, paste it, delete at. It is, I think, fourth, right? 1, 2, 0, 1, 2, 3, 4. We are starting from the index 0. Okay, so fifth one we need to delete. Normally fifth one we need to delete, but index wise fourth we need to delete. We have a temp variable. Okay, so this temp variable needs to this 4. So we have an index. Let's take an index variable. Index. Okay. Okay. So when we travel from one point to another, we will increase this. Correct?
yes, yes.
Index plus plus. Okay. Then your condition should be if
Index becomes equal to
index equals to 4. Correct?
yes, yeah.
Okay. So you have reached over here. The temp has reached over here. Now tell me what you will do.
Then what you have to do is the temp of next is 500.
Hmm.
That you have to place it on
Temp of next. Okay. Temp of next. I have.
this temp of next you have to update. You have to assign to temp.
Okay. Equals. You're saying. One
Temp
second.
equals to temp of next.
1 second. I'll just make this a little longer. So you're saying if once we have reached here, I need to do it temp equals to temp of next.
Yes.
Okay. So now
No, not sorry. Uh, Previous node you have to update with 500. So wherever you have that
previous
the
node you means to say here.
yes, in that
You're saying that temp equals to temp of next. Okay.
yes,
We're traveling also like this only, no?
yeah, but we have reached that fourth index.
So temp equals to temps of next. This one.
Yes.
But temp of next is this one, no?
Yeah.
So
So that
you are over
index.
here. That is
Yeah.
4,000.
Ideally, to delete that fourth index. So previous node we have to
You
update.
can have this one also. Temp of next to next. Correct
Yeah.
now?
Yes.
This is the other way also. But we normally don't do that. We are like a swapping of variable we use. This is a little confusing. If you give something like this, normally no one will understand. There will be a problem in understanding this. Okay. So if so you want to stop at this place, correct?
Yeah.
So we need to have something like not index. We'll have a loop. We will have something called as I. I should be equals to uh, index minus 1. Correct?
Yes.
Whatever the index is, we need to have this one. Okay. Correct now?
Yeah.
Okay. Once we got that, we will need to update this one. Oh, 1 second. Give me 1 second, huh? Okay, so we will have something called as node to delete. Once we reach over here, we will have a temporary variable called node to delete. We need to delete this node. Okay, so we'll find the place where we need to delete. Suppose I have taken, why I need to have it, because we need to free this node. For example, if you directly connected that next to next also, right? You reached of this point, right? You have this next and you have next to next. You can directly put 500 over here. You don't need to do anything. You just put 500. How you will put? You will put simply like temp equals to temp next correct.
Yes.
This we can done easily, but what happened is this memory, there is a space in the heap, this memory is there, you have not deleted it. Once
Yeah.
you connect it directly to this point, this is gone. Nothing is holding it. So what will happen? What kind of issue we are creating?
Dangling pointer.
No, it's not dangling. Pointer is not
No.
dangling over. We will have something called as memory leak.
Yes.
So we need a node, we need a pointer that can point this one. Okay.
Yes.
Okay, so once we got that, so we'll point to this location. So how we will point it? We will have something like node to delete equals to temp next. Okay, we have something like this. So what this contain? This contain the address 4000. Correct?
Yeah.
Okay. Now we need to have this statement. This one. Temp equals to temp next. What is temp next over here? If I write the same statement, temp underscore, so this should be something like this actually. I just missed writing it. It should be written something like this. Temp next equals to temp next. Correct? Huh? I'm putting 5,000 over here. I'm removing it. So I'm putting 5,000 over here. So this is correct. This statement is correct, right? So how we can do this? We can put it like temp next equals to node to delete next. This both statement and correct only, na? Look at them very carefully and let me know if you are see what is temp next. Temp next is Pavan, are you there?
No delete.
No delete. What is this temp next? Node delete next.
Yeah. Correct.
So now temp next equals to node delete next. So we will have placed this 5,000 over here. What is the benefit we get from doing this is we still have one pointer which is pointing to this particular 4,000. So we can delete it. So we'll write the function, we'll test it. Okay.
Yeah.
1 second. Okay. Open this one. So we'll have a non-returning void delete AT index. You'll have an integer, same name, right? Int index. Okay. Okay. It will have a structure because we need a new node, correct? Struct node, and this will be a temporary one. For what purpose? To travel. We need temp, right? We have seen over here that we need temp. So this temp we needed, which is equals to head. Then we'll travel for Okay, and I'll just close this thing first. And I equals to 0. Temp is not, sorry, not equals to null. Null, it not reaches till the end, or I is, so you can directly rise for, this is like a protection thing. Stamp not equals to null. Okay, for handling the corner cases, suppose someone has index -1, because we have seen that we need -1. Correct, right?
Yes,
I
yes.
plus plus. Till here. And here we will have this temp equals to temp next. So we are traveling till what we found. We found null, found the null, or the index is -1. I will travel till I. Suppose we travel till this one, 4,000. Okay, here temp next will be 4,000. So temp will be 4,000 will stop at when temp is 3,000. Okay. Okay, so we'll got this 3,000. Once we have got this 3,000, we will create a structure. Struct node star, star node to delete node to node to delete equals to what we have written, temp next. Correct, right? We have discussed over here.
Yes.
Okay, and temp next means temp next will be, we'll copy this one, node to delete
Next.
next. So our this deletion is completed. Now we just need to release the memory.
No. No
How
to
will
delete.
release? Yeah, we'll just put it, and everything is done. So this is our program. We need to have this deletion at 2. So we will have like 10, 20, 30, 40, and 50. Our linked list will be like 10, 20, 30, and till 10 to 50 it will be there. And we are deleting at the point 2, which means 0, 1, 2. So 30 needs to be deleted. Let's see. Let's compile this. Okay. Link. Okay. As you can see, 30 is gone. So any doubt in this function?
No.
No doubt. Okay. I have some doubt. Can you solve it? Okay.
Yes.
What happen if index is 0?
Index 0.
If index is 0, then it will be -1. Then it can crash, right?
Yes, yes.
Or head is not there. First thing is head is not there. Head itself is null. Nothing is created. If someone wants to delete it, then it will create a problem, right?
Yes.
What we need to do is we need to check what head should not. If head is equals to null, or
If
index.
it is not null, then you can go inside. Or equal to null.
We will be having a reverse way. Okay, so if this is index is less than 0, or it is null. So what we will do, we'll return. Return. Okay, now point is, what type of function we have? Sorry, what type of function we have? Void type, na? Return type is void. We
Yeah,
cannot give
just
it
for
zero. Yeah. Or what you can do is you can create a abstraction throw also, you can put integer as well. It's based on your design. Understand? So if head is null, or if the index is 0, means index has not been created, there's nothing in this. So at that point of time, if someone has given -1, -2, so your whole program will be not useful, right? Why
yes.
to travel through down and create a memory and all, do all that stuff? There will be created, this will be created. Here we are going to, this is not there, then also it is going to be done. Suppose if the index someone has given -1, what will happen? You will go inside this this temp will be created, correct? Then it will try to travel, but index is -1, so this loop will not work, but this loop will work, right? We'll create a node, then it will create a temp from unknown memory.
Mm, not able to hear.
Hello.
Yeah.
What's the issue? I think he's facing some internet issue or something else.
Hello. Yeah. Till where you have I have explained. Hello. Hello. Is I'm audible? Pavan, is you are there?
Yes, sir. Yes, I'm there.
Okay, so till where I have explained. Okay, so I will repeat once again. I will repeat it once again. So what happened is, for example, if you give a negative index, okay, if you given a negative index, what will happen is this line will not work. Only this line will not work. Everything else will work, correct? We'll create a node and we will have a temp variable which is pointing to a head, where head is nowhere, so it will pointing to an unarbitrary situation somewhere in the memory, and this will create a issue.
Yes, yes.
So that's why we need to put this one null. So your task will be, next task will be that you will create a same delete function, okay, and in this delete function you will not see it by the index, you will see it by the data. How you can do it by the data, can you explain me if possible?
Yeah, you have to do temp of data.
For
Once if
example,
you,
for
yeah, you're
example
saying,
I want to delete this 1001, means from 10 I need to delete, wherever 10 is deleted, or it might be a multiple cases also. For example, here also this is 10, okay,
Mhm.
here the 10 is also there, and it might be a multiple case. And tell me how you can delete, and how many times you need to delete, how many time you will travel the list, and what you do.
Yeah, in that case, like you have to go with temp of next equal to null, means we'll traverse till end.
Okay.
Then uh, temp of data is equal to 10 is the condition you have to put.
You are over here. This 10 will be missed, right? If you reach till null, this 10 will be
No, no.
missed.
I'm
You are
telling
saying, you are telling during the
the
traveling
you have to
time you will
put,
check the data.
yes, yes.
Okay, you will
We
check
are
the
inside
data.
while condition.
Okay,
So
so
with the while
the
condition, we
so your
are
loop,
traveling.
you are saying you will start from I equals to 0, and you will be like when the temp value uh, equals to null, you will be reaching till that when temp equals to null. Okay, and during this traveling you will check if condition data equals to 10. Okay.
Yes,
Okay, so then what you will do?
temp of same temp of next. Next we have to update with temp of next.
Okay. Okay, then if this is done, then the loop will be over, or you are saying that the same condition will work until we reach to the null.
Yes, yes.
But this is for the index, unit index as well, right? How will you do it? I mean, index
Without
is
index also we can do it.
okay. You are saying that index is already there. With the index, you are traveling in the but you don't need an index right now, correct?
Yeah. So without index also we are using while temp of next equal to null.
For
Then
you need
so
to point.
add,
For example, here also you need this index for, especially if you know the number, then only you can use this logic.
no, index is not required. We are passing the data there instead of index. Uh, Now we are passing the
Okay,
data.
you have passed the data. Then no, I'm not saying that here you need to require. Here this logic needs required index, right? And
Yes.
so suppose, okay, you suppose over here you get this point, you get this temp. Okay, then this point to delete. Okay, you are saying that you will in the same way which for loop you will find this particular from if condition you will find this one, and this in the inside this if condition you will write the same logic, and this will be went till the null. So how many times that data appears, you will just replace the data, correct?
Yes. Yes.
Logic is fine. But here we are getting this 3000 only, we are getting this. I mean, we are stopping at this point, temp equals to 3000, but you will be stopping where the temp equals to 40. Why? Because here you are having this minus one, but there
No,
you have,
no.
okay, okay, let's do one thing, you try it. You'll make that program. It is, I
Yeah.
think, easy to for you to do that. Okay, so I'm just sending this updated program to you. I think the only this is required. List of other thing I have covered previously only. So only this one is required. Deletion. Uh, Valmiki, did you have provided the last week this one program?
Last week program I shared on chat already, and I
Okay,
think
okay,
video I will share today. Hmm?
okay. I will write the whole program then. 1 second. I think I have this. Get put it into the commit part. Wait. Control X. Yes. Get add hyphen. 1 second. Hmm. 1 second, I'm giving you the program because it's difficult to copy from here. I will copy from my Git link. Okay. So where is my GitHub? DSA. Here is the code. Okay. So share it in the group as well. This one. Where is this? Valmiki, can you share in this WhatsApp group as well?
Yes, let me
Hello.
copy it. Yes, let me copy it.
Okay. So this is today's program. Okay, let's have a little other topic other than this one. Okay. So now we have created the data structure. Let's take the use case of it. Okay. So did you heard of a stack? What is stack? Pavan, are you there?
Yeah, I am there.
You heard of word stack?
Yes, yes.
So what is a stack? And did you have created a stack any time in your life?
Yes.
With what?
I think I coded very long back, 4 years back.
Okay, so then we will start with a very simple stack. Okay, what we are doing in this stack is we will having 3 functions. Okay, push, pop, and peek. Push, you understand that. Okay, let's see what a stack is. For the other people, might be they are not aware of. Okay, they will watch the recordings. Okay, suppose we have some data. Okay, so stack is a bundle from, for example, you have a stack of 10 integer. It means from it will start from 10 and it will go to up. So you will put the value like 11 over here, 12 over here, 13 over here, 14 over here, 15 over here. We're giving the theory part. 16 over here, 17. Let's take this much. 17, 18, 19, 20. Okay. Beyond this region, the memory is not there. So we cannot push. Rule is it should be limited. The memory is limited in any resources. Okay. System, any type of computer is there. If you fill it, it will be going out of the stack. So this is called there is a limit for the stack. Okay, and how the stack is removed is like in the reverse order. If you remove this, you want to use this 20, you remove this 20 and you get a vacant space. That is called pop. So it is like a first come last out type of thing. This is called a stack. Okay, so how we can make a stack? Do you have any idea which data structure we can use to make a stack?
Array.
Array you can create. Okay, and how will you be managing all of that? I mean, you have a array, and how will you design push method or pop method or peak method? Understanding point. I'm saying you need to create a this one object. Okay, so tell me in the way of array. For example, we have a array. This is array. Let's be like putting it green color. Green color means it is an active. Suppose we take a 5 example of 5 arrays. Okay, 5 element. So this is our stack. You can put it in that way also. So as we have seen the array is always this linear. Okay, so this is the 0th index and this is the 4th index. Correct?
Yes.
Okay. So how will you so what is the first function? This push. Correct?
Yeah.
Push means
Adding the value.
ARR, yeah, ARR of whatever the number. Suppose like number. Sorry. Push means some sort of number will be there. Okay. What is the range of number in this case? It can be a range between 0 to 5. Okay, let's design a stack, a simple stack. Okay.
0 to 5.
So 0 to 5. So push means just filling the value of the array is pushing. Correct?
Yeah.
Correct or not?
Yeah.
Okay. What is popping? In this case, not in the other case. What is pop?
Removing an element. Removing the first element.
Okay, how will you remove the first element? Tricky question, right?
Yeah.
Suppose, okay, let's see. Pop will be in the end. Suppose you have written 1, you have written 2, okay, you have written 3, you have written 4, you have written 5. Correct? Okay. So how will you delete this fifth number?
Reduce the size.
You will reduce the size. How can you reduce? You already given this 5, na? This is array. For this case only. This is array. This is a technical questions. Nothing about the stack and all. So this is an array. One way is you will put something over here. You can put a null value. But it is also like filling only. Correct?
Yes, yes.
Correct. Okay. Suppose I say that, for example, the printing of this number. For example, I have 1, 2, 3, 4, 5. Okay. Suppose I want to pop this 5 out. I don't want this 5 out. So I will take the value from this. Suppose I want to pop fourth element. What I will do is I will have an integer which is like value. Okay. And what I will say is value 2 is, so it will be like array of 5. Whatever the element at the array at fourth place, just give me that. That is popping. Okay. So here I get the value that is popped. But now I shouldn't have the permission to access this particular fifth. The 5 is already there, but I should not able to use pop it back. Okay. So for pop function, you need to create something. For example, we have a, let's take an element. Let's take a variable into account, or we can say as like manager. We have something a manager number. Okay. So every time we push something, this manager will be incremented. Okay. So 1 is pushed, this manager become 1. 2 is pushed, manager become 2. 3 is pushed, manager become 3. 4 is pushed, manager become 4. 5 is pushed, manager become 5. Now, when we pop that instruction, I mean the pop that particular value, this should be decreasing. When we are doing popping, it should decrease. And popping should be done at this particular point. POP pop. Okay. Pushing will be happening where? When the number is increasing. If it is become 5, then we cannot push. So what will happen? We should put a condition that if the manager is greater than 5, it should not push anything.
Yeah.
Okay. And if the manager is less than 0, we should not pop anything. So this manager number, which we call as top of the stack, top of this is nothing, just a manager number, which will manage your number. For example, you are over here, you are at the 1. Suppose you are at this position which is called 1. So what top will be 1. Now what you can pop is, because the value is 1, you cannot more than anything which is 1. So you need to put a condition that you can only pop, the value is 1, you can only pop the last element which is 1. So if you write pop, nothing to put, you don't need to give the index and all. What will happen? When you write pop, what will happen? It will return what? ARR of top minus 1. Okay, it will return this one. So this is pop. What is push? Correct? This is
Yeah.
correct, na? What
Yeah.
is going to be push? ARR of
So
ARR of sorry. Why this is
top equal to data.
top minus 1
Yeah.
equals to data. So in this way, we will created a function using this top. Is it okay? It is understandable?
Yes.
Okay, so next week we will see the practical part of it. So how the top is working. First we will see with what? First we will see with array. Next we will see with linked list. Okay. Next we will see with vector or list. So we will see this, that how this stack is going to work. Once we done the stack, we will go to queue. Okay. So this is try to make this program if you are able to, and try to make the program with the deletion with the certain element. There is 2 condition in deletion. Try to do it. We will meet next week.
Love our content? Hit subscribe for more awesome videos. We'll see you in the next one.